often, a lot of laboratories in different industries, for example, rubber and tire manufacture, they have these insoluble solid samples that are not dissolvable in any type of solvent. So that's really where pyrolysis GCMS comes in place by broadening the range of organic material that you can analyze. Could be solid or semi-solid, liquid, or even semi-liquid samples. So you just simply place your sample into this inner sample cup and you can perform the analysis. Also, pyrolysis GCMS enables you to perform detailed material characterization on complex samples. Either could be polymers or copolymers or blends or also additives. So these are a couple of main reasons why a lot of laboratories are integrating pyrolysis into their day-to-day analytical protocols by really extending the capability of their GCMS systems.
Speaking of the structure, the micro-furnace technique or micro-furnace pyrolyzer has a low-mass ceramic heater that heats and cools rapidly. And then also it ensures the thermal uniformity by guaranteeing the pyrolysis temperature reproducibility within the range of ± 0.1 degrees C. And unlike other pyrolyzers, the micro-furnace pyrolyzer protects the sample from any exposure to heat before the analysis. It means your sample is not degraded and you do not lose additives, volatile information before the analysis. And another is the direct contact to the GC inlet without a long transfer line. All the pyrolysates after the pyrolysis are transferred rapidly and directly into GC columns. So this simple step analysis performs you to do the entire characterization of volatiles, additives, and polymers.
Analytical chemists, we all appreciate and we all know each instrumentation has its own benefits. So they are like a tool in our toolbox. And if you already have Raman or FTIR in your lab, adding pyrolysis GCMS will become the final piece to your capabilities in your lab. It actually provides a more comprehensive and more detailed analysis to your material characterization while it's complementary to your FTIR and Raman technique in your lab. For example, with FTIR, you can obtain information about the functionality groups of your sample, while the pyrolysis GCMS provides detailed compositional and structural information about your sample. Also, with pyrolysis GCMS, you can analyze those insoluble dark colored samples that really opens a new door for you to be able to characterize a wider range of samples in your laboratory.
Micro-Furnace GCMS system can solve many things for many different applications. For example, let's say automotive parts or paint, coating, textiles or oil and gas, even the microplastics and forensics. One of the example is let's say if you are, there is a manufacturing company that produces automotive parts, and now they are facing product failure. So what they do is to pyrolyze your sample and then to find out the cause of failures. So based on the pyrograms that obtained from the pyrolysis, they tackle and then identify what is the compositional information from their failure products. And then another interesting example is museums. So what they do is they analyze the art object to identify and then confirm the origin and let's say history, background, and even the authenticity of the art object. And also, the recent interesting example is the microplastics and nanoplastics in the environment. So pyrolysis-GC system can identify and even quantify microplastics in nanoplastics in air, water, and in soil.
With Micro-Furnace, you can perform multiple analytical techniques. You can do either thermal analysis, like evolved gas analysis, or you could do separation analysis, like thermal desorption, or flash pyrolysis, a double shot, or a hard cut. So yes, at the beginning, if you are new to pyrolysis world and new to Micro-Furnace, it could look and feel challenging for you. But we have a couple of tools that really help our beginners, our new to pyrolysis world, to feel more comfortable and to feel more expertise in this industry. The first one is our method map, the chemical method map, which is a series of techniques that guide you step by step of how you could characterize your samples. The first step is to perform your evolved gas analysis, which is a thermal analysis, and that gives you a clear picture about the thermal profile and thermal complexity of your sample. Once you have that EGA thermogram, then you could decide on what will be the appropriate separation analysis that you could perform. Would I want to do a flash pyrolysis? Would I want to do a double shot, or which is thermal extraction followed by flash pyrolysis? So really, EGA thermogram guides you on what to do next. And then the second factor that really helps our beginner and users in general are our F-Search interpretation libraries. F-Search is a mass spectral search engine that has 4 unique libraries of EGA MS, additive MS, pyrolysate MS, and also polymer. And you can also create your own in-house user library within the F-Search engine. But what's powerful about F-Search, which is for identifying your polymers and additive, is that with the Pyrolysate MS library, not only F-Search will tell you, okay, this peak corresponds to this specific compound or pyrolysate, but also will tell you where the source of origin of that pyrolysate could be. Because with pyrolysis, as you know, you break down your polymers into smaller pieces that are called pyrolysate, and then you'll be able to identify those pyrolysates to corresponding polymers. So F-Search really helps you on identifying the pyrolysate and where they could be coming from, the source of origin of each one. So I think these 2 tools really help our beginning and Micro-Furnace user to become more expertise in this analytical technique.